So we're working on only 3.5 today. I did also already upload the review sheets. There's like 3 review packages that I put up. So if there's no reason you should run out of review. But I put down the main one that you should be following. Then I put some 2 extra ones if you want some more extra work to practice. If you're not sure, you can definitely use that to practice. So please keep that in mind. We do have those. So yeah, today only 3.5, so let's get this started. With 3.5, we are now going to our last lesson, okay? We are now going into our last lesson of the day. Who just came in here? Sina just came in. Okay, I gotta update the attendance here real quick. Whoops. So once again, we're going into our last lesson of our Unit 3, which is the solving linear systems algebraically. Okay. Hello, Sina. So let's talk about this. Let's review first. Let's recall our information. So when we're checking, if anyone wants to type in chat, feel free to type in chat. Like when it asks us, which of these points is on the line, what is it asking us to do? How do we check if it's on the line? Anyone know? We do the left side, right side check. Okay? So in other words, we're going to plug in these points into our equation, and then we're going to check our work. So for example, left side, right side. The left side is y. The right side is 3x minus 7. Plugging it in here, y sub in. So we're going to sub in negative 2, 1 here. And so plugging in y as 1. On the right side, we're going to plug in negative 2 as x. And then we solve that out, negative 6 minus 7, and we get negative 13. Does the left side equal right side? Left side does not equal right side. Therefore, negative 2, 1 is not on the point. So we've done this before on our previous test on Unit 2, right? Where we do the left side, right side check to make sure or to double check whether a point is on a line, or to check our answers as well. We've done that too, right? So with the equation here, right? Same equation, we're going to use it left side versus right side. The left side is still y, the right side is still 3x minus 7. And this time we're going to sub in our second point, which is 5, 8. When we plug in 5, 8, we're going to get on the left side, we get 8. And on the right side, we get 3 times 5 minus 7. 3 times 5 is 15. And 15 minus 7 is 8. And what do we get? We get left side equals right side. Therefore, 5, 8 is... Oh, I wrote a point here. It should have been on the line. Whoopsies. Is on the line. That's the important part. Okay, so we have left side equals right side, therefore 5, 8 is on the line. That's the important part here. Okay. So when I'm asking you to check points, like is this on a line? We've done this before. We plug it in, we do a left side, right side check. The reason why we're doing our left side, right side check is because we want to make sure that our answer is correct. So let's continue on to the second part. What are the important terms of this lesson? So let's talk important terms. The first new term that's important is something called a linear system. So a linear system is a set of 2 or more linear equations that represent relations between the same 2 variables. So if we have y equals mx plus b, the second equation would also be y equals mx plus b, and x and y represent the same things. The second term here is point of intersection, which I will also call POI. And the point of intersection is the point where two or more lines cross. So when I draw two lines and they meet, so if I draw any two random lines like this, the point in which they meet, this is called the POI. Okay? And the
Isn't
last one,
perpendicular?
sorry,
Yes.
say that again. Jim?
Isn't perpendicular the same thing?
Perpendicular means that they cross at 90 degrees.
Yes, I know.
But the point of intersection is specifically just talking about the point.
You cross any line that isn't perpendicular.
Yeah, it doesn't matter if they're perpendicular or not, wherever they meet is called the point of intersection. So it's a little different. And the last thing here, the solution to a linear system is the point of intersection of the system. So when I'm asking you to, hey, solve the linear system, you are finding the point of intersection. It's just another way to say solution. So let's take a look at this lesson here. To solve linear systems, we need to find the point of intersection. That's the goal, right? So if I ever ask you, once again, please solve this linear system, you're finding the point of intersection, where the two lines meet. The point of intersection is the solution to the linear system. It is the point that satisfies both relations. So the point that is common between the two lines. So there are three different solutions that a system can have. It can have one solution, right, which is here, where they cross at one point. No solution, where they don't meet. Now, what's important about this? No solutions. What does that mean about the two lines if they never meet?
It's parallel.
Parallel. Thank you, James. Perfect. It's parallel, and you guys already know that that means that the slopes are the same, right? And the last one here is infinitely many solutions.
Two lines are on the same thing, on the same one.
Yeah. In other words, the lines are overlapping, right? It's the same overlapping. It's two lines
Overlapping means infinite solutions.
Yeah, because it's always touching, so it's always going to have infinite amount of point of intersections, right? All the way across. So that's why it's infinitely many solutions for this last one here. Okay, so there's three. One solution with one point of intersection, the POI. No solution means the slopes are the same, and infinitely many solutions. This specifically means that the slopes are the same as well. Slope is the same, and y-intercept is the same. This is really important. Okay, both conditions have to be true. Okay, if the slope is the same and the y-intercept is also the same, then it has infinitely many solutions. Okay, so there are some quick ways you can check whether it has no solution or infinitely many, and then you'll actually have to solve it for the one solution. So let's go over the steps in how to do so. Okay, I made these bigger because it's important. So step one, graph the two lines on the same grid. Any method of graphing can be used. You can use the slope and y-intercept. You can use the x and y-intercepts, or you can use a table of values. I am not picky. You get to choose your way of graphing. My mark that I give on your test is mainly about, hey, can you graph it correctly? Are your lines drawn correctly? So when you graph it, please make sure you are using the right values. Very, very important that you do so. Okay. Step two, determine the point of intersection of the two lines from the graph. And then step three, verify your solution. Check your work. Is it true for both equations, not just one? Okay, because the point of intersection exists, both lines pass through that point. So it better work for both equations. You have to do both checks. Okay. So we're going to use these 3 steps to solve our equations, our systems. So example 1, solve the following system, this and that. Verify that your solution satisfies both equations. So we're going to check and solve our following system. Okay. We need to graph it. Step 1 is to graph it. We're given it in y equals mx plus b form. So I'm going to find my slope. So I'm going to call this equation 1. Okay. And I'll call this equation 2 in red. Okay. And I'm going to solve for my slope and y-intercept. So for equation 1, my slope is 3 and my y-intercept is -5. When you graph that, we plot -5 first, and then we draw our slope, which is 3 over 1, right? So we're going up 3 and right 1. Up 3, right 1. Up 3, right 1. And I can keep drawing that out. I'm just going to draw the dots to save a little bit of time. Okay? If you can connect that with a ruler, even better. Draw a nice line going through all the points. That'd be perfect. For equation 2, the slope is -4 over 1 because it's -4. And the b, the y-intercept, is -2. So we draw our y-intercept first on the y-axis at -2. And we go down 4, 1, 2, 3, 4, and right 1. So we get this. Down 4, right 1. And then we can go backwards as well. We get this. So now I'm going to draw my lines. Let's draw that line there. Beautiful line. And then for our second one, draw another line. All the way down like that. We'll draw it red. Perfect. So there's our 2 lines. Okay. Now for this one, you'll notice, oh, that's not very nice. So we need to determine from the graph what is our point of intersection.
I just found it.
Yeah. So we can approximate it here. I'm going to zoom in a little more just so I can see a little better. Right? So where your 2 lines cross, it's not going to be very nice here, but we're going to approximate it. And I'll say in orange, oh, it's this point right here. That's where they cross. That's our point of intersection. If you were to put down some coordinates on it, I'd say approximately 0.5, comma, let's say that's a little past -3. So we'll call it like, let's say -3.6 or 7-ish.
7. 7.
Yeah, so 7. James saying 7, we'll do 7. Something like that. Now, I'm not going to have to check. I didn't think that this would give such a terrible point of intersection, so we're not going to verify for this one. We'll work on the verification on the next one. Sorry, guys. But this is how you find your point of intersection. Can you graph it correctly, right? And then once you graph it, can you see where do the 2 lines meet and state your coordinates? So we would say the POI is 0.5, comma, -3.7. And that would be your solution. There's one solution to this system. Okay? Any questions on this graphing and finding the point of intersection, or do you think it's pretty not too hard?
It's easy once you get used to it.
Perfect. That's what I like to hear. Hopefully everyone else also has that kind of same sentiment. No one came to after school help yesterday. I stayed for 30 minutes by myself in a Zoom meeting. So I'm assuming everyone's doing good. Example 2. Solve the following linear system. We have y equals negative 2x plus 5 and y equals x minus 4. So once again, I'll call this equation 1 and call this equation 2. We'll do the same thing. Equation 1, we have the slope is negative 2 over 1 and the y-intercept is 5. For equation 2, we have the slope is 1 over 1 and the y-intercept is negative 4. Drawing my first equation, we start at y equals 5. The y-intercept is 5. And the slope is negative 2 over 1. So we go down 2, right 1. Down 2, right 1. Down 2, right 1. And we can do that. There's our line. And then we can also do our equation 2, which starts at negative 4. Y equals negative 4. We draw our negative 4 point, and it goes up by 1. So 1, 1, 1, 1, 1, 1, and just like that. I think some of you can probably already see, oh, Mr. Choi, I already see the point of intersection, which is fantastic. So let's draw that out first. So there's our first line in red. And then we're going to draw our second line as well in black. And with orange, we're going to show our point of intersection, which is right here. Right? That's where the two lines cross. This one's very clear what the point is. What's the point here? 3, comma, negative 1. We have our coordinate. That's our point of intersection. That's where the two lines meet. So we can say POI is equal to 3, negative 1. Now comes the checking. Okay, so to check equation 1, we have left side and right side. I should probably zoom in a little more here. Sorry, 1 second. Let's do that again. So for equation 1, we're going to check equation 1, which is y is equal to negative 2x plus 5. So we're going to plug in our point of intersection here. So our left side, right side. Our left side is y. Our right side is negative 2x plus 5. We're going to plug in 3, negative 1. So on our left side, we get negative 1. On our right side, we plug in 3. And the left side's already solved. It's just y. So on our right side, negative 2 times 3 is negative 6. And then plus 5. Negative 6 plus 5 is negative 1. And then we can write at the end, left side equals right side, check mark. We're good. That point is definitely on that line. Then we're going to check equation 2. So checking equation 2 is y is equal to x minus 4. And so we do our left side, right side table. Left side is y, right side is x minus 4. Left side, we plug in y as negative 1. On our right side, we can plug in 3 minus 4. And 3 minus 4 is negative 1. And so left side equals right side. And we're done. So now we've also checked our answer by plugging in our point of intersection into both equations and verifying that the point exists on both lines. Okay? Are there any questions here? All right. So I think we're good here. Example 3. Solve the linear system. Verify that your solution satisfies both equations. So this one here, we have it in x plus y equals 8, x minus y equals 4. We're going to try graphing this using our x and y intercepts instead. Okay? So our first equation, let's say you're like, I don't want to rearrange this for y equals mx plus b. Mr. Choi, I hate rearranging my equation. I'm just going to solve for it. All right, absolutely. Let's solve for it. So for equation 1, for the x-intercept, we can say that y equals 0, and plugging it into my equation, x plus 0 equals 8, and so x equals 8, so my point is 8, comma 0. There's my x-intercept. For my y-intercept, same idea, except x equals 0, and we have the equation x plus y equals 8, 0 plus y equals 8, so y equals 8. Pretty simple. And so our final point is 0, comma 8. Once we have those 2 points, we can draw that out, which is 8 and 8. And we can connect that with a line. And we're done. Whoopsies. We draw a line that goes through it, and voila, there's our line. Right? That's all you have to do once you find your x and y intercepts. For equation 2, same thing, x-intercept. We have we have for our x-intercept, y equals 0. Hello, eraser. Thank you. So y equals 0, and the equation is x minus y equals 4. We plug in y as 0, and we're going to get x equals 4. So my coordinate is 4, 0. For my y-intercept, we are plugging in x equals 0, x minus y equals 4, 0 minus y equals 4. We're going to get negative y equals 4. So we do need to divide by negative 1 here. So we're going to get y equals negative 4 as my point. So that'll be 0, negative 4. Once we have that, we can plug that in. Our x-intercept is 4, 0. Our y-intercept is 0, negative 4. And we can draw our line. Like such. And voila, we have our 2 lines. And I think you can already see our point of intersection. Let's do purple here. All right, so we have our point of intersection, which is right here. What are the coordinates for that? What is the point of intersection here that I drew? Anyone? 6, 2, yes, but don't use a slash. You want to use a comma. 6, comma 2, right? Because it's a coordinate. Because 6 slash 2 is going to be like 6 over 2, right? Like dividing. So 6, comma 2 is what you want to write. So 6, comma 2. So my point of intersection, you write it at the end, 6, comma 2. Okay. Now we have to check our work. So we're going to go through our checking. We're going to check equation 1, which is x plus y equals 8. Okay. So our left side equals right side. Our right side is 8. So we don't really have to solve anything. Our left side is x plus y. So we're going to plug in 6 plus 2 as our point, and we get 8. Does left side equal right side? Absolutely. Left side equals right side. Check. For our second one, check equation 2. We have our original equation as x minus y equals 4. So left side, right side table. Right side is 4, left side is x minus y. Plugging in my point, I get the x as 6 and the y as 2. And we're going to get 6 minus 2 is 4. And so left side equals right side. Check. We're done. So that is definitely the solution. So this
Good.
is the full thing. Okay? Notice how I'm plugging in the point of intersection here, right? We're checking our solution. I'm not using the x and y intercepts. There's no point doing that. We're checking specifically our point of intersection when we check our work. Okay? Any questions? That was the last example here in terms of graphing linear systems here. So what I said was when you check your work, you are plugging in your point of intersection into your equation. That's what we're checking. We have to check our solution, the point of intersection. All right. Moving on. Example 4. Ooh. Word problems. We
I
got word
love it.
problems. Ah, I love it too. Example 4, word problems. So high school theater companies earn their income through startup grants and ticket sales. The graph shows the relationship between income in dollars and number of tickets sold in and then N as the variable. Now, if I ask you first question, Santiago, I'm going to choose you first because you're the first on my list on my right side. Santiago, what is the independent variable and what's the dependent variable? Not yet, Milana. Santiago, you there? You got if you don't know, say I don't know. Saying nothing doesn't help me. Okay. Sina, can you tell me what the independent variable is and the dependent variable, please? All right, Sina's silent too. Milana, what is it? What's the dependent variable and what's the independent variable? Oh, there it
No,
is.
I'm not silent. Hello?
Milana said the dependent variable is income, the independent variable is number of tickets sold. Absolutely. So the independent variable, which is our x variable, right, is down here on the x-axis, and our dependent variable is on the y-axis, right? We know that's our x and y. So our n is technically x and our I is technically y, right? So this is just to get you used to creating equations if you need it, right? For something like this. Okay? So the first question here, we're going to work on this together. James, you're the first one on my list next. If 30
All right.
tickets are sold, which company makes more money?
If 30 tickets are sold, if 30 tickets are sold, does company A or B make more money?
Yeah.
It's company A.
Company A, right? It's very obvious, right? We
Extremely.
looked, yeah, it's very obvious. So this is the 30 mark, right? And if we look up at the 30 mark, company A is a higher income than company B. So clearly, company A makes more money, right?
Yes.
Perfect. All right, next up. Elia, you're next on my list. What does the point 20, 200 represent? Not yet, Milan. We're going to give everyone else a chance as well. We're on question B, Elia, not question A. Question B. I think you're misunderstanding the question. You might be misunderstanding the question. Gerald, do you want to give it a shot before I explain the question? What does the point 20, 200 represent? Point where both companies meet. That's a good start. So first, Gerald says the point where both companies meet, which means, so this is 2200 here, right? That point, that purple point on the graph, and Milana is saying it's the point of intersection. So Gerald and Milana have both said it is the point of intersection. Which is true, but that's not what I'm asking for. Remember, the word represent is specifically asking you in terms of this question, this word problem. What does that point mean? You both are correct. Like Gerald and Milana are not wrong. They are right. It is the point of intersection, but that's not only what I'm asking for. So when I'm asking, hey, what's the point of intersection? This is what I'm asking for here. So I'm gonna bring my good old text box here. So the point 20, 200 represents when both companies make the same income.
2,200, make 200 for 20 tickets.
Okay, this is what I'm looking for. This is the explanation I want, right? This is to help me understand that you can clearly see that both of these companies are making the same amount of money. And yes, you can argue like Mr. Choi, obviously that's what point of intersection means, but I want you to communicate that to me, right? If someone asks you this, right, what does that mean in this situation? It means that both companies make the same income for 20 tickets. That's what it means, right? So that's what we want. Okay, that's the explanation we want. So Gerald and Milana are right, but it's not exactly what I'm looking for here. Okay, so a little bit tricky. Question C. Under which conditions does company B make more money? Suyang, you are next on my list. Which conditions will company B make more money? One sec. Suyong might be typing something. That's why we're just waiting. Don't know? Okay, that's okay. Mercel, you want to give it a shot? Which conditions will company B make more money?
Below the condition of 20 tickets sold.
Say that one more time louder.
Below the condition of 20 tickets sold.
Yeah. So if we want to kind of word that just a little bit better, you're right. I know what you mean. Company B makes more money. I'm reiterating what he said. So I'm writing down what he said. So Mercel said company B makes more money if they sell less than 20 tickets. That's what he said. Okay, that's what Mercel said. So he said company B makes more money if they sell less than 20 tickets. And let's look at that. On the graph here, right? When it asks us when does company B make more money, we clearly want to see company B's line higher than company A's line. So when is company B's line higher? And company B's line is higher during this section. And that section,
When they're selling between like 10 to 20, 0 to 20 tickets, I think it's like
yeah.
10 makes more money.
Yeah. So anything between 0 to 20 tickets will make more money, right? So anything between 0 to 20 tickets, company B makes more money. At 20 tickets, company A and company B make the same amount of tickets. And then after 20 tickets, company A makes more money, right? Company A makes more money. Hey guys, I know he's loud. It's fine. It's just the mic. There's not much we could do about that. Everyone's mic is different. Just like how Mercel was quiet, right? It's thing. That happens. That's the thing about technology. It's all over the place. Okay. So with that information, we can clearly tell. So there are situations where I may even ask, when does company A make more money? When does company B make more money? Like, when do they make the same amount? You should be able to analyze the graph and identify where that point is. Okay. So with that being said, this is the condition, right? Company B makes more money if they sell less than 20 tickets. That's the condition. They have to sell less than 20 to make more money. The moment they pass 20, they start making less money than company A. So that's the idea here. Okay. Are there any other questions of clarification?
Is there a D?
Is there a D? Question D? No, not for this part.
Okay.
Anyone else? Going once. Going twice. Okay. So then we have our practice and homework. There's question 1, 2, 3, and 4. You'll notice 3 out of the 4 questions for 2, 3, and 4 are word problems. Okay. So as a class, vote. On question 1, would you like me to do part A or part B? For question 1, part A or part B?
Where's the poll?
No poll, just type it in chat.
I'm going with A.
Okay. All right, looks like majority is saying B, so we are going to do B. I think we only had 2 or 3 people say A, so majority is B, so let's do B. We have our 2 equations here, okay? When you're given in y equals mx plus b form, immediately you should probably head towards stating what the slope is, which is 1 over 2, and the y-intercept. This allows you to graph it right away. So plugging that in to my graph, the y-intercept is -3, and the slope is 1 over 2. So we go up by 1, right by 2. Up by 1, right by 2. Up by 1, right by 2. And we can keep drawing that all the way across. Just like that. And so that's going to be my first line. My second line is not in y equals mx plus b form. Now, those who are comfortable, right, can change it to y equals mx plus b form. If you do so, you should get y is equal to -x minus 6. Okay? This will give you your slope of -1 and your y-intercept of -6, and you can graph it. I'm going to redraw that 6 because that looks like my B. Okay? So that being said, let's say you forget. You're like, I really don't like changing it to y because I'm x plus b form. Then you can solve for your x and y intercepts, right? By plugging in y equals 0, which will give you x plus 0 equals -6, which gives me x equals -6 or -6, 0. And for my y-intercept, we plug in x equals 0, and we're going to get 0 plus y equals -6, and y equals -6. So 0 and -6. So it doesn't matter which method you do. As long as you pick one, go for it. So if I plot using my y-intercept and my slope, my y-intercept is -6, and my slope is -1. So down 1, right 1. Down 1, right 1. Right? And you'll notice if we keep going, we actually meet our x-intercept anyways at -6, 0. See that? So doesn't matter which method you use of graphing, you meet the lines anyways. So when we insert our line here, our shape, drawing my line, there's my first line, just like that. My second line, oh, oops. My second line will look here, like such. And so, let's see, who hasn't answered? Rowie! What's my point of intersection here? We need our final answer. Point of intersection, what is it? Perfect, thank you. POI is -2, -4. Correct. Done. That's solving a linear system by graphing. Okay, that's all you have to
How
do.
we find the final answer?
Sorry, say that again, Sina?
How did he find the answer? Final answer.
Remember, the final answer, the point of intersection is where the two lines meet, right? So that's the x and y coordinates of that line.
So how about the second one?
That's this here.
Oh,
What do you
negative
mean
2.
by
Oh,
answer?
so we see -2 and -4.
Yes.
So yeah, I see it.
Okay. So that's how
There is
you're
a question.
solving linear systems by graphing, and you're going to do question 1A on your own, for homework, that kind of idea. Okay. Then, for our final question of the day, can you pick question 2, 3, or 4? So type it in chat. Which question do you want me to do? Question 2, question 3, or question 4? Pick one.
Can you tell me what they are?
You don't have it printed?
No.
Well, it's on the screen.
So first is Mac, second is something else, and Netflix, and I'm going with Netflix.
Okay, number 3 for James. Gerald and Mercel saying number 4. Elia number 3. Santiago going 4. Yep, read them first. So far we have a tie. There's no number 1, it's number 2. So it's either question 2, question 3, or question 4. Suyong saying 4, Santiago saying 4.
For what?
Okay, Milana's saying 4 as well. So majority of people picked question 4, so we're going to do question 4. So question 4, at Lowell High School, the cost to attend special events depends on whether or not a student has purchased a $10 discount card. Option A, the student buys a discount card. The cost is $5 per event. The student does not buy a discount card. The cost is $7.50 per event. Graph the relationship between total cost and number of events for each option on the grid. Then part B, determine the conditions under which a student of Lowell High School, sorry, it's a typo, should choose. When should they choose each option? Okay, so we have the number of events on X, we have the total cost on Y. Option A says they buy a discount card and every event after that is $5. Okay, cool. For option B, they don't buy the discount card, but every event is now $7.50. Okay. How should we graph this is the question, right? So there's a lot of different ways you can do it. Okay. The first way you could do it is a table of values. If you want to do a table of values, you absolutely can, right? You can set it up as X, Y, and plug in your points. So for example, I'm going to do option A down here, right? I'm going to say option A. I'll zoom in. So I know I'm using the bottom spaces so I have a little more space to work with. So for option A, with our XY table, right? At 0 events, remember, option A is when the student buys the discount card. So how much money have they used? They used $10. For option A, at 1 event, they now have to pay another $5. So the total is now 15. Option 2, two events will now bring it to 20. 3 events brings it to 25. 4 events brings it to 30, right? So that's for option A. For option B, using our XY table here, at 0 events attended, they only have to pay $0 because they're not buying a discount card. But if they go to 1 event, they are now paying $7.50. At 2 events, they are now paying $15. At 3 events, they're paying $23.50. And at 4 events, they are paying $23.50 plus $7.50. I'm doing the math wrong. Oopsies. It's $31. Okay. Oh, sorry, not 23.5. I did the math wrong. I'm a math teacher and I'm doing basic addition wrong. Uh-oh. Sorry, $22.50 and then $30. That's my fault. Sorry. 30. So $7.50, $15, then $22.50, then $30. Okay. We can go one more if we want to go to 5. And that would be $37.50. And on the left side for $5, it would be $35. Okay. You can graph it like this. There's your first example. The second thing you can do is say for option A, looking at my explanation, the cost is $5 per event, which means this is my slope. And they buy a discount card for $10, which is my fixed cost. Which means option A, you can immediately say that's 5x plus 10. For option B, they don't buy a discount card, so there's no fixed cost, and $7.50 per event, that's the slope. So the second equation is 750x. Right? So there's 2 ways you can graph it. Create your equation, graph the slope and y-intercept, or draw a table of values. Drawing my table of values, I can plot it right away. 0.10, 1.15, 2.20, 3.25, 4.30, 5.35, and I think we can see where this line is going depending on how many events the person attends. For option B, it's a little trickier to draw because we are drawing 750s. So it starts at 0, 0. Then for 1, 750 would be around here. $15 is here. 22.50s around here. 4.30. And then 37.5. And we kind of can't draw that perfectly now, so we can actually just include our lines. So I'm going to draw my first line. Voila, absolute beautiful art, such as Mr. Choi's amazing art. And the second one is going to be our red line here. Trying to go through all of this line as best as possible, and we do that. Okay. So notice how the question doesn't ask us what the point of intersection is, but the question does ask us what are the conditions on which a student should buy each option. So the students should purchase option A when what? When should these students purchase option A? So right now we have this is option A. And this is option B. Yes, Mercel, feel free. What's the condition? Just say for option
When the
A.
number of events is below 4.
When the number of events is below 4. 4 events. Okay. Someone else want to go tell me for option B?
Oh wait, I made a mistake. That's the opposite. After
Okay.
after 4.
So is above 4 is what you mean, right? So option B then would be when the number of events is below 4. Okay. And the reason why this is the case, in the last question that we took up together, that was a word problem, we looked at income. And income, higher number is better. We want to make more money. But in this case, these students are spending money. So does a person want to spend more or spend less? And the option is obviously spending less. If I saw a PS5 on sale 50% off, I'd obviously get it for 50% off than I would get it at its regular price. We want to save money. Money is amazing and we want to save it as much as we can, right? So when it asks you when should the student choose the option, you're looking for the cheaper option. And so when it asks us option A, when is it better? We look at when option A's line is lower, and it's lower than option B after 4 events. So if the student attends more than 4 events, option A is better. Option B, however, right, is better when they choose to go to less than 4 events because the line is below the other option, right? So this is the understanding and explanation you want to give, right, for this word problem. All right. Are there any questions about this? Going once, going twice. All right. So that's going to be it for today's class. Your homework is to complete the rest of the questions we did not do for this sheet. So question 1A, question 2, and question 3 are your 3 things you must complete for tomorrow. Should I do another homework check tomorrow? What do you guys think? Should I do another homework check tomorrow? Nah, I'll be nice. I won't do a homework check tomorrow. But please have this done so that we can take it up tomorrow. I will be taking up this work tomorrow, so please have that complete so that we can go through it with relative ease. Tomorrow we'll also be starting our unit test review. So please have the unit 3 review printed and ready to go, not the extra review stuff, just the original review first. The extra review is just for you in case you want more. I've also posted some challenge questions for linear systems if you want to give those a try as well. If you can do those, you've gotten this concept fully. Otherwise, that is it for today. I will see you tomorrow at 2 p.m. Yes, you don't need me to send me the homework. No, I'm not going to check it. So we're just going to take it up together tomorrow in class.
Goodbye then.
But give it a shot. Give it a try. So take care, everyone. I'll see you tomorrow at 2 p.m. Try not to be late. Peace out, guys. Also, if you have song suggestions, I'll post an announcement on Google Classroom if you want to share songs. Bye, Elia. Bye, Mersal. Bye, Milana.
What are songs for?
Just in case people come early, we can play some songs that people suggest.
Do they have to be appropriate?
Yes, please.
Right.
Highly prefer that it is appropriate.